Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem. Count the submatrices with equal frequency of x and y. Given a 2D matrix grid where the grid of I is either x or y or dot. Return the number of submatrices that contains grid 0 0, which means we need to include the top left um, element every time, and the equal frequency of x and y and at least one x. So in this question we are given a grid which contains values as x, y and dot, and we need to count the number of submatrices which will start from this top left corner and which will contain equal number of x and y and at least one x. So this is a similar question that we have solved yesterday in daily problem. So what we need we need to include this column, the top left 0 0 0 0 column. So we will find the frequency of x and y for every cell in this matrix, and we gonna use the concept of prefix sum or the pre-computing. So what we are gonna do is for example, if we are standing at this index, what we are gonna do, we're gonna use the number of x and y's in this submatrix and this submatrix. So the number of x and y in this submatrices, if this column is x or y, we will increment the x count or y count according to that, and we will just add the count of the x and y in this submatrix, which will have 0, 0 to 0, 1, and also we will include this submatrix which will start at 0, 0 and 1, 0, and we have included this submatrix twice, so we will just subtract it 0, 0 from the result. So that's how we're gonna calculate the submatrix sum of every cell ending for every submatrix ending at that currently cell. So let's look at the code here. We will have this vector of pair. We will have vector of pair, because we're gonna have a grid of size n cross m, and every cell contains pair because we need x count and y count. Currently the answer will be initialized to 0, and we will iterate till I is less than n and j is less than m. So we will have this x count and y count. If the current grid's value is x, we will increment x count. If it is y, we will increment y count. Then we will check if the previous row is present or not. If it is present, we will increment x count by v I minus 1 j first, because first element is the x count, and increment y count according to that. If previous column is present, then we will increment x count and y count according to that. And if x minus 1 and y minus 1 column is present, we have included this part. For calculating this, we have taken these two submatrices, but we have included this part twice. So we will subtract the x count and y count from the submatrix I minus 1 j minus 1, and in the end we will check the condition if x count is here, because we need at least 1x, and y count and x count is equals to are equal, then we will increment res, and in the end we will just fill v vector with x count and y count. So in the end we will return res. So the time complexity will be big O of n cross m. Sorry for the disturbances. So time complexity will be big O of x cross n, and the space complexity will be x cross n, because we are using this v vector. So guys, if you find this video helpful, please like this video, subscribe to the channel. Thank you.